So, good evening, everyone. So, welcome to my YouTube channel, Math Shastra. So, today we are going to see third property of Jacobians. Third property of Jacobians, or you can say property third. Okay. So, if U, V, and W of 3, if the functions if the functions U, V, and W of three independent variables x, y, and z are not independent, then then Jacobian of u, v, w with respect to x, y, z is zero. Okay. So before starting this, what are the dependent? We have to prove this, but we have to see what are the actually uh, independent, not independent functions. Okay. So dependent functions means dependent functions. Dependent functions. The functions the functions u, v, and w of independent variables x, y, z are said to be dependent if u, v, and w are related by some function f. u v w is equal to 0. Okay. Okay. So note that if u, v, and w are dependent, then u, v, and w are called functionally related. Okay. Second, if u, v, and w are dependent, then u, v, and w are called independent, not independent. The functions which are dependent, they are called also not independent. Okay. And if functions are dependent, they are also called functionally related. Okay. The three names are there. So let's prove third property. If variables, if u, v, and w functions are independent, okay, sorry, if u, v, and w are dependent, then their Jacobian becomes zero. Okay, becomes zero. We will prove it now. Okay, so let's prove it. Proof. U, V, and W are not independent. Therefore, they are related by this function, some function. Okay. Now let's say this is star differentiating partially with respect to x, y, and z. We get, if we are differentiating partially with respect to x, what will get? Del f upon del x. Okay. By using chain rule, what we get? Del f upon del u upon del x plus del f upon del v upon del x plus del f upon del w upon del x is equal to 0. Del f upon del u upon del y plus del f upon del v upon del y plus del f upon del w upon del y. Okay. And del f upon del u upon del z plus del f upon del v upon del z plus del f upon del del W upon del Z is equal to 0. Okay. Let's say it double star. Okay. Eliminating, eliminating, eliminating del F upon del U, del F upon del V, and del F upon del W from 3, from double star. We get, we get what we get? We get this determinant is 0. Del U upon del X, del V upon del X, del W upon del X, del U del Y, del V del Y, del 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 W del Z, del U del Z, del V del Z, del W del Z. So here Y will come here. That is going to be 0 because we have eliminated del F upon del U, del F upon del V, and del F upon del Z. Now, because in determinant we can change row to columns. So then what we will get, that is del U upon del X, del U upon del Y, del U upon del Z, del V upon del X, del V upon del Y, del V upon del Z, del W upon del X, del W upon del Y, del W upon del Z. Okay. So what is this? What is this? This is nothing but Jacobian of U, V, and W with respect to X, Y, Z. That is 0. So prove. Okay. Now convert. We want to see its sufficient condition. Converts the sufficient condition if it is given that del U V W del X Y Z is equal to 0 and U V W are not independent, Okay. Are not independent of one one another, then they are connected by a relation FUVW is equal to 0. Okay. So now see example. If U is equal to X Y plus Y Z plus Z X, V is equal to X square plus Y square plus Z square, and W is equal to X plus Y plus Z. Determine whether there is a functional relationship between U, V, and W, and if so, find it. Okay, find it. Solution. So, what is del? What is Jacobian? Let's calculate Jacobian. So, del U upon del X, what is this? Del U upon del Y, del U upon del Z, del V upon del X, del V upon del Y, del V upon del Z, del W upon del X, del W, del Y, del W, del Z. So what is this? Y plus Z it is. Okay. Z plus X it is. X plus Y it is. 2X, 2Y, 2Z. 1, 1, 1. Okay. So apply R1 is equal to R1 plus R2. So, sorry. First take 2 common outside. So it is Y plus Z, Z plus X, X plus Y, X, Y, Z. Okay. Now applying R1 goes to R1 plus R2. Then what we will get? We will get 2 times x plus y plus z, x plus y, x plus y plus z, x plus y plus z. Okay, x, y, z, 1, 1, 1. You can take x, y, z common. 1, 1, 1. X, Y, Z. Now we have a determinant in which two rows are same. So what will the value of the determinant? 0. 2x plus y plus z is equal to into 0. So finally we got this is 0. So this implies del u v w with respect to x, y, z is 0. So this means that this implies that u, v and w are functionally related. Functionally related. It means they are they have functional relationship. Okay. So if they have functional relationship, we have to find it. Okay. Now you see that it's the v square. This is nothing but x plus y plus z का square. That is x square plus y square plus z square plus 2 times xy plus yz plus zx. So what is the value of this? This is nothing but, sorry, uh, it is w square. So what is w square? This. And what is this? This is v. And this is what is this? This is u. So what we got? We got this one. W square 2u plus v. Okay, so this is the functional relationship. Now move to second example. Second example. Verify, verify whether the flowing functions, flowing functions are functionally dependent, functionally dependent, and if so, find the relationship, find the relation between them. Solution. So functionally dependence means also they are functionally related or they have functional relationship. Meaning is same. Okay. So what are the functions? So functions are u is equal to x plus x plus y upon 1 minus xy, and v is equal to tan inverse x plus tan inverse y. And now what is Jacobian of ub with respect to xy? What is this? This is del u del x del u del y del v del x del v del y. So what is the del u upon del x? Del u upon del x will be equal to, so calculate del u upon del x here. Del u upon del x is 1 minus xy square, 1 minus xy with respect to x minus x plus y minus y. So what will be this? 1 minus xy square and plus xy plus x plus y square. Okay. 1 minus y square. So it is 1. Sorry, it is 1 here. So 1 here means no power will be there. 1 minus y square. This is cancel out. So this is 1 plus y square, 1 minus xy square. Okay. Similarly, what will be? Similarly, what will be del u upon del y? What will be del u? Okay. So it will be 1 plus x square, 1 minus xy square. You can check it, you will get this. Okay. So put these values here, 1 plus y square, 1 minus xy square, 1 plus x square, 1 minus xy square. What is the partial derivative of, and what will be the del v upon del x? Del v upon del x will be 1 upon 1 plus x square, and that is 0. So 1 upon 1 plus x square. Del v upon del y, what will be this? 1 upon 1 plus y square. Put these values here. 1 upon 1 plus x square, 1 upon 1 plus y square. So what we will get? When we multiply this, 1 plus y square will be cancelled out. So I am writing it 1 minus xy square, 1 plus y square minus 1 plus x square, 1 plus x square, 1 minus xy square. If this will be cancelled out, so this is 1 minus xy square upon 1 minus xy square. This is 0. Okay. So what we got? We have del u v upon del x del y is equal to 0. What does it mean? It means u and we are functionally related, or you can say, or you and we are functionally functionally dependent. Functionally dependent. Functionally dependent means they have some relation. No, what is the now what is B? B is nothing but tan inverse. We have to find relation between U and B. What is the formula of this tan inverse? That is nothing but tan inverse x plus y upon 1 minus xy. And now you see what is the value of inside thing? That is value of U. So we have put a value. So tan V is equal to U. It means U is equal to tan V. So this is the relation. Okay. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you for next lecture. Okay.